let's go ahead and mark this. So this is Monday, September 21st, 7:51 a.m. Cool. So where are we at? Welcome back, scholars and warriors. We're going to jump right in where we left off, which was on the story of the atom. And we've gotten as far as the Bohr model, and I'm ready now to introduce to you how to both show the Bohr model, and we're also going to try to get into electron configuration. If not today, hopefully we can set it up for the next class. I am good to go. So I'm not going to do too much review. Some of that you can just go back to the previous video and check it out, but I am going to set a bit of the scene. So our essential question remains the same, which is how the arrangement of the electrons, and that's what we're focusing on now, how electrons are arranged, and then we'll get into the light piece later. You saw the series of experiments that got us to the Bohr model, and now we are going to look at the Bohr model itself. So I think I'm going right into the back page. After we finish the Bohr model comes the periodic table. I think we're good. All right, so this is the second page of the notes, which you should probably have already copied. And rather than try some elaborate explanation, I think it's really best just to offer you the rules that go with this and just give you time to practice. Okay, so I'll give you some of these rules. We'll model a few, and then you'll go right into the 16 folds where you'll get a chance to actually draw it. I think after you draw it a few times, you will see how the pattern unfolds. So let's get into it. The Bohr atomic model. Excuse me. As you guys know, protons and neutrons are found in the nucleus. So when we draw the Bohr model, what we're going to do is indicate, just like a small periodic table tile, what is the atomic number and what is the atomic mass for that particular element. And that will give us information as it relates to what is inside the nucleus. But we will just show the nucleus as a small dark dot in the middle. Next, the electrons fill in a specific pattern. And when I say specific pattern, I mean very specific. And so I am fully going to expect you to put the exact electron in the exact correct location for its final configuration. I'm going to show you that pattern today. Electrons fill into energy levels. We recognize 4 energy levels, which are simply numbered 1, 2, 3, and 4. And each energy level can hold a maximum number of electrons. The first energy level can hold a maximum of 2 electrons. The second energy level can hold a maximum of 8 electrons. The third energy level can hold a maximum of 18 electrons, plus 10. And then the fourth energy level, which would be plus 14, can hold a maximum of 232 electrons. So the first one can only hold 2. The second one adds a new orbital, which is called the p orbital, and that holds 6. We'll get into it. Let me not stress you out about those details. All right, so what I am going to do is turn this into a table, and then I will probably add some color to the table. Now, what I could have done at this point was asked you guys to predict, but I haven't introduced the periodic table. So I'll say it this way. When we get to the periodic table, and you will either go to your own electronic version, or if you have a printer, you can download one from the internet and use it as a paper version. You will see how these numbers came up. So I'll get into that when you actually see the periodic table. I think it'll be a little more clear. What's my next point here is electrons want to be far from each other until they are forced to pair. Okay, we'll see that in the pattern. Well, listen, I could do a bunch of explanation, but I find the best thing to do in terms of showing you the rules for making the Bohr model is just to make the Bohr model. So what I'm going to do today is start with two elements, one that I would consider relatively simple but demonstrates the pattern, and then one that takes it all the way there. So the first one, I'm actually going to pull out a periodic table and put it over here to my side. If you have a periodic table and you can put it on the screen or do some kind of side-by-side, I would recommend you do that. All right. I think the first one that we should do is lithium. So in the model, what you're going to do is an Li, let's put it here, Li. If you go to the periodic table, you get the atomic number and the atomic mass. In this case, I'll go ahead and pull it out since I have it here. The atomic number is always the smaller of the two. Typically, there are two numbers in the box. A whole number can be identified as the atomic number. Generally, it's on top of the box, but not always. People make them look however they want. The atomic mass is typically shown as a long decimal. It is always, forever and without exception, the larger of the two numbers. Okay, maybe a few exceptions. What else can I say? It is generally found on the bottom, but not always, okay? So when you look at any tile on the periodic table, there are typically two numbers. Make sure you know which ones are which, and you will be expected to round the atomic mass number to a whole number. So in our particular case, and I will be looking for this, the atomic number goes on top, and we will assign lithium a 3 on top. What that does, atomic number tells me how many protons. There are 3. The bottom number is the atomic mass. In this case, is 6.941. I'm rounding that to 7 because 6.9 rounds to 7. So you're going to need to perfect your rounding skills, because if you look closely, these numbers that you have to round are all over the place. I think that's what I have to show you for that. So then let's move on to drawing the model. So what you're going to do, and in this case, I know what to look for, so I know to give myself enough space. This element fills 2 energy levels. How do you know that? Because lithium is on the second row. So all of these elements will be found on the second energy level, which means these on period 3 will be found on the third energy level. Okay, we'll get into that detail a bit later. And what else do I know about lithium? Well, here are the rules. I think we just do it. So I draw myself a nucleus, which is shown as a dot. The information about the nucleus is what we do up top. I draw the first energy level, which is simply a circle around the nucleus. Okay. Now keep in mind, this circle is actually meant to represent a spherical shape, and the electrons are moving in a 3-dimensional space so fast that it appears as a fog or as a haze, which we call the electron cloud. But what it actually is a very fast-moving electron. Think about a fan or tires on a rim. If you look at the rim, sometimes it's moving so fast that it appears more solid when it's not. Same with the fan, it can appear more solid when it's moving very fast. All right, so the next thing is filling in the electrons, and that's what this whole process is really about. So when you're filling in electrons, what you need to know is the first 2 electrons go on the right, and the first energy level holds a maximum of 2. So if I was to do hydrogen, for example, I would just do 1 and it would be on the right. If I assigned you helium, you would do 2 and they would both be on the right. But since I assigned you lithium, and lithium has an atomic number of 3, its neutral version would also have how many electrons? Finally, getting into the zone of getting my chat warmed up. So let's make this the chat question. I'm 10 minutes in. It's a perfect time to get some participation rolling up in here. So if lithium has 3 protons, it has an atomic number of 3, put it in the private chat. How many electrons would it have? And let's assume that it is a neutral element, okay? In the meantime, I'm going to continue drawing my circle, and I look to see your responses in the chat. Remember, it's participation, so give me an answer. Even if it's a wrong answer, you're going to get points. Okay, I am going to now draw my second energy level. Now, the thing that I learned about drawing energy levels is you want to make sure that the energy levels don't touch. For me, it doesn't have to be a perfect circle. I've been doing this a long time, so my circles have gotten pretty good. But I promise you, I would rather have a imperfect circle, but the energy level far enough that the electrons don't touch each other. That's really important to me. All right, by now the chat should be full, so we're going to go ahead and score those of you who have participated. Thank you very much. Lithium has 3 electrons because it is neutral. So since there are 3 protons, there are also 3 electrons. Now, this will give us a chance to see what happens in the second energy level. The second energy level, we've noted, can hold up to 8 electrons, okay? This particular element has 3 electrons. I've put 2 on the first energy level. The third one goes on the second energy level. And it goes in a very specific location, which is on the right. It would go here. And this, ladies and gentlemen, is the electron configuration for lithium using the Bhor model. And this is classic Bhor model. There are other models, but I'm teaching you the very classic traditional version. Okay, next thing I'm going to ask you to do is to put this in a box. Let's go ahead and box this off. Maybe I meant to say put it in a rectangle. We're going to try, I think we can fit 1, 2, I think we can fit 2 more in here. So let's move on, mosey on along down the periodic table. How about oxygen? Oxygen sounds good. Okay, that way we're still staying on the second energy level, but we get to see more of how the pattern develops. And I'll give you the heads up right now. The pattern is right, top, left, bottom, right, top, left, bottom. Okay, so here we go. Let's jump in. We're only 2 minutes later, but it would be a good time to practice our participation. So if you would hit me in the private chat, we're going to analyze oxygen. First, would you tell me what is its atomic mass? Make sure you round properly. While you guys are putting that in the chat, I'm going to set up our note here. So we're going to do oxygen and its atomic. Let's go ahead and bring it into the frame here. Here I found oxygen on the periodic table. Whatever periodic table you're using, get used to referring to that. So even though I'm putting mine up, this is the one that I like, so I'm going to refer to this. But if you have one on your screen, I would recommend that you look at the one on your screen and get very familiar with how the tiles look and all of that. Okay, so I'm going to actually take my periodic table off the screen and recommend that you focus on the version that you like. Okay, so first find the atomic number, and in this case, when you look on your periodic table, you should see 2 numbers, and one would be a whole number, one would be a big decimal number. One is smaller, one is larger in value, and one is, I don't know where they were located, but the atomic number is 8. And the question I have for you is the atomic mass. So I see some of the chats are rolling in. Thank you guys for participating. The atomic mass, if rounded properly, is in fact 16. So I'm going to get you guys scored up for that while we work the electron configuration, or what they may call the Bhor model, or what they may call the atomic model. Okay, so all of these refer to the same thing, which is a 2-dimensional version of an atom actually in 3-dimensional space. All right, so how do we start? We start with the nucleus in the middle. Now notice that I've given myself some room on both sides, so you also want to use this to practice your spacing. And what else can I say? If you haven't figured it out, chemistry and all of the sciences do have a relationship with artists, and so those of you who are art-minded, I hope that you do well, because we do lend towards your sensibilities. All right, moving on. Let's draw the first energy level. Now, let us do a little bit of processing here. We know the atomic number is 8. That means it has 8 protons. And we can therefore conclude that it has how many electrons? Somebody can hit me in the chat. It won't be for points, but at least, you know, you can check your knowledge. Yep. So yes, the answer is also 8, because it is neutral. Later we might do some charged, but I might just save that for the most advanced students. It's not really required for learning the Bohr model. So we know there are 8 electrons, and we have to fill those electrons in a particular pattern. How many electrons fit on the first energy level? Put the answer in the chat. How many electrons can the first energy level hold? And the correct answer is 2. And where do we put those 2 electrons? Some of you have already answered. Thank you. We put them on the right. Okay. Now you'll see I made that line a little bit bigger. So now my next energy level has to be a little bit further out, right? So what I'll do is, I don't like starting not at the top. So I'm going to still start at the top, but just try to give myself a little more space. And now I'm drawing the second energy level. Bam, like so. Okay. Now I have the second energy level. According to our notes, the second energy level can hold up to 8 electrons. Now, please remember, we have already placed 2 of the electrons. So how many electrons do we have left? I'll let you answer in the chat, just a volunteer answer. In the meantime, for everyone else, after you answer, let's think about placing the electrons using the pattern. This is electron 1 and 2. So then this one will be number 3. And we got to count until we get to 8. Okay? To count until we get to 8. So this is 1, 2. 3 goes on the right. 4 goes on the top. 5 goes on the left. 6 goes on the bottom. 7 goes on the right. 8 goes on the top. So notice it's a bit of a backward circle. Okay. Let me refer you also back to our notes before we move on to our final, most complicated example. Electrons want to be far from each other until they are forced to pair. And what that means is what we see here. Okay. I will put it as far apart, then on the top, then on the left, then on the bottom. And then I have to start pairing them. Boom, 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 boom. Now, some students erroneously, wrongly, incorrectly want to just evenly distribute all 8 around the energy level, and that's not appropriate. Okay. The most appropriate thing to do is to go right, top, left, bottom, right, top, left, bottom, until you run out of electrons to fill. Okay. And then they will all end up being placed. All right, guys, very good. So what we are going to do now is move on to our third and final example, and then I will offer you our assignment. We're at 18 minutes so far in today's lesson, so I feel like I'm doing really good on time. Okay, our last one is going to be a little bit more complicated. Therefore, I'm going to try to leave maybe more room than I think I should. We have all this space here now to do our last one. And I think I want to pick a big one. Maybe something on the 4th energy level. Which would be, I'm going to do number 19. Or do I do calcium? Maybe I should do calcium. Let's max out. I'll promise you this. If I ever ask you to do a Bohr model, I will not go past calcium, number 20. So if you understand how these electrons get placed properly, these 20 electrons, then you can probably do them all. Just follow the pattern. Okay, so what we're going to do here is do our setup. So why don't I actually give you guys a second to set it up yourself now that you've seen it. What I'd like you to do is place your elements symbol, which in this case is Ca. place the atomic number and the atomic mass. Please make sure that you round properly. That's good. To the nearest whole number. All right. I'm going to go ahead and jump in at this time as well. So I'm going to put mine here, kind of center with the space that I have left, CA. And I'm looking at 20 on top and 40 on bottom. I underline that. We're looking good so far? Okay, what's the next thing that we would do? Draw the nucleus sort of as equicenter as you can, right? To have maximum space around. Now, how many electrons do we need to place? We need to place 20 electrons. Okay. How many fit on the first? 2. How many on the second? Up to 8. On the third, up to 18. Okay. So you're going to see how we start to get these things placed. Now, there is something called the octet rule. And this is now time for me to demonstrate the octet rule because it applies. So, matter of fact, 21, I guess I'm going right into it. I'm actually going to refer to these concepts and then draw the last one. Okay, these bottom notes, you've already have them written down, so it should be just a good opportunity for us to stop with this model and flesh it out. Before I add new concepts, let me actually stop and see if anybody has questions. If you have questions or you don't understand this, put a 3 if you are in the middle. If you are lost, not confident, put a 1. And if you are feeling good, 1, 2, 3, 4, 5. 5 is not a standard number that we use. Let's do this. Grade yourself on a 1 to 4. I know I'm making it more complicated than I should, but it'll give me a better sense. If you kind of see how this pattern is going, grade yourself on a 1 to 4. How strong do you think you understand this idea? While that's happening in the chat, I'm going to explain these concepts. Okay, valence electrons are the electrons in the outermost energy level. So in this case, for lithium, the valence electrons would be 1 because there's only 1 electron in the outermost. Whereas for oxygen, how many valence electrons can you count? It would be the ones on the outermost ring. And in this case, we're looking at 1, 2, 3, 4, 5, 6. So we said that oxygen has 6 valence electrons. Electrons in the outermost ring. Okay? Octet rule says that elements will do things. And this is where we get introduced to chemical reactions in order to achieve a noble 8 configuration. I'm not going to over-explain that now. It will become clear as we do more of this. What I will say about the octet rule is that the outermost energy level can hold no more than 8 electrons. The outermost energy level can hold no more than 8 electrons. If you still need to place electrons after the 8th one, then you need to go to the next energy level in order to place them. Okay. That is why calcium is next, because we have to do that for calcium to work. So let's go back to the beginning, use what we've already discussed, and then apply some of this new knowledge, okay? When you're placing the electrons, we know we need to place 20 of them. We start with the first energy level. First energy level around here. Then, how many electrons? Where do they go? I'm going to encourage you to place your electrons first, and then I will place them hopefully after you. And if you use pencil, that's even better. Bam. If you can, no, I don't think you can finish. Let's just continue on. So then second energy level, because this one is now maxed out. Get your circle, practice your art. Remember, I'm not here to judge your circles. Do the best that you can, erase it if you need to. Let's continue to place electrons. Here I've placed 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we've gotten to the point that we have filled the second energy level. And as it so happens, it has 8 electrons. But the rule says no outermost energy level, no valence energy level can have more than 8. So either way that it goes, we have to push on to the next energy level. So out we go. Okay. Now, if we get a count of where we are so far, we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're about halfway there. Then we go here 11, 12 on top, 13, 14, 15, 16, 17, 18. Okay, we're up to 18. We have met our octet rule. There's 8 on the valence on the outermost, which means once we get to number 8, we have to go out again. We were at 18, so where does 19 go? Always on the right. And 20 will go on the top. This is the electron configuration for calcium. I'm going to go ahead and stick with my pattern and put this in a box as well. And that's the play. All right. How do you feel? How do you feel? Put your assessment in the chat. Give yourself a 1 through 4 now. This is the one that I need to say actually counts. If you get it, you're feeling good, give me a number. I'll give you your participation credit. If you're not feeling it, then I want to know, because this is the end of our lesson and we are now launching into your assignment. This assignment you can do on your own, but the picture is what you will post to me in Google Classroom later on this week. You should have a paper, whether it's printer paper or line paper, really doesn't matter, that we have already folded into 16 squares. Okay, what I want to do is to give you the elements that you need to make the Bhor atomic model for. Okay, and so lithium was the one that we've already done. I'm not going to do it again because it's already in your notes. Okay, so all I'm going to do is go ahead and post the elements that you need to do in the box in the chat, and you guys can fill it in as you see. What else can I say, fam? That's it. I think this will be a fantastic assignment. If you have questions, comments, or concerns, you know what to do. Find me on GChat, shoot me an email. We can set up a time to do Zoom during office hours or whatever it takes for me to help you. And this will be fantastic practice, and we will take it from there. All right, peace.